Now, myself, Subhas Das, Assistant Professor of CSE, AI and ML. Now, I am going to explain a very important and very curious topic of operating system, that is deadlock. Deadlock. Now, I explain what is deadlock, why deadlock happen, and how to avoid the deadlocks. Before going to the deadlocks, I try to give some basic idea about the process and resource. You know that every process is going to execute with some resources. I know that process have several steps. First, we have to create a process. After creating the process are go to the ready mode, means it's go to the primary memory. Why primary memory? Because when process start, process stay in the secondary memory. We cannot access the process directly from the process secondary memory to processor, because the speed is different. So process there need a primary memory. So when process go to the primary memory, then it can access by the processors. So process go to the primary memory, then it's allocated to processors. During processing, processes needs some inputs like input output device or any printer or any other file systems maybe. So these are the resources. So here, if a process is running and this process during running wants some resources, but these resources may be allocated by the others resource processes, this condition is called the deadlock conditions. Actually, what it's happened, deadlock condition why happen, there are the four necessary conditions for deadlocks. If these four conditions simultaneously happen, then we call that system is in deadlock condition. What are the four necessary topics? First, mutual exclusion. Mutual exclusions means I tell that process need resource to complete the process. Okay, but here a process P is running. He needs a resource R, but this resource R have only one instant, means only one resource there. So if this resource may be allocated by other resource, means this process cannot take this process. So if a system having a resource with one instant, means it's have only one resource, one piece of resource, this type of resource not shared by any other process at a time. For this reason, deadlock may be happen. This condition is called mutual exclusions. The second condition is hold and wait. Suppose there are two processes running simultaneously, process P1 and process P2. Now, process P1 hold a process, that is R1 hold a resource, process P1 hold a resource R1, but he want another resource that is called R2, but somehow this R2 is held by the process P2. So P1 cannot complete without R2. R2 is held by the another process P2. So this condition is called hold and wait. If a process holding a resource and waiting for the other resource which is held by the other process, then what happen? The time when P2 is not release the R2, then only P1 can receive this. So it's a long time. For this reason, deadlock may happen. So this is the second condition. What is the third condition? Third condition is no preemption. No preemption means if a process is allocated to a particular resource, now another process need this resource, but we cannot forcefully take away the resource. That condition is called no preemption. If we forcefully taken the resource and give to another, then deadlock not happen. Means if there is no way to forcefully taken away the process, then the process whatever resource is allocated, it's allocated to the particular process till what time it's worked. So we cannot forcefully take away the resource. For this reason, deadlock may be happened. And last that is number 4, that is another circular wait. Now we go with an example, like there is a process P0 which is hold a resource R1, okay, and request for the resource R2. This R2 is held by the another process P2. P2 request for a process which is P2 request for a process R3 which is held by the P1. So there is a circle where a process, first process want a resource which is held by the other process want a resource which is held by the another process, like that last resource is held by the first process. So there is a circle, they are made a circle. So this type of waiting is called circular wait. So if these 4 condition is simultaneously happen, then I told that the deadlock happen in the system. Now we just take a glance with a graph. So we used a graph, that is resource allocation graph. How we create this graph? Here we denote circle for the process and the square for the resource. Okay, now if process P1 is hold process resource R1 and process P1 request for the resource R2, resource R2 is hold by the process P2, process P2 is hold request for the process resource R3, where resource R3 is held by the process P3, and P3 requesting for the process R1, like that. So this condition we see that process P1 requesting for process R2 which is held by the process P2. Process P2 is holding process R1 which is which is held by the process P3. Process P3 requesting a process for R1 which is held by the process P1. So there is a circle. Here we check that there made a circle. If there is circle in resource allocation gap, this gap is called resource allocation gap. If there is a circle in resource allocation gap, then I can say that there is a deadlock. But circle in resource allocation gap not the sufficient condition to say the system is in deadlock. Why? Because if this resource have two instance, like you have two printers, then what happened? There are two instant. So one process is uh, taken printer 1, another process may taken printer 2, so both are taken two printers. So if the instant is more than one, then maybe there is a circle, but deadlock maybe not happen. For this reason, you have to mind that circle in resource allocation gap is not sufficient for the deadlock. It is a necessary conditions but not sufficient conditions. So these are the basic idea of deadlock. Now I tell in small what is the way to overcome the deadlocks. There are many ways. First, deadlock prevention. Deadlock prevention, how we achieved? We have to remove all the four conditions. First, mutual exclusions. So we have to put many resource, many instant of resource. Like printer, you have to put three printers. Input device, we have to put two or three input device, like that. Mutual exclusion. Hold and wait means we have to make a state that one process which hold a resource should be checked whether his another resource may not be held by the another resource, like that. So third condition, there should be a mechanism for preempting the resource, like that. Force these four condition we have to overcome to prevent. Another way, that avoidance, deadlock avoidance, how we can achieve? There is a popular algorithm called bankers algorithm. Using bankers algorithm, uh, we can make a safe step, which by which sequence, or safe sequence by which sequence we can go allocate the resource, that deadlock not be even, not be happen. So another thing, that is deadlock recovery. If somehow deadlock is happen, means we have to recover the deadlocks. How we recover? Similar to the bankers algorithm, we have to use a safe step, or we have to achieve a safe step to recover from the deadlocks. And first we have to detect deadlock, and then we have to recover the deadlock. And last, that ignorance, deadlock in ignorance means we have to ignore the deadlocks. Many operating system do that. They seems that deadlock is not a big problem, so we can avoid this because this is very costly, so they avoid it. So according to the today's session, what we are going to summarize: deadlock is a condition where one process is uh, try to complete its execution using resources, but if the resources is not available in the system, then only deadlock may be happen. There are four conditions: that mutual exclusions, hold and wait, no preemption, and circular wait. We also learn how we can overcome the deadlock condition. So these are the basic idea about deadlocks. I hope everyone understood little idea about deadlocks. So thank you all.